multi. And for our purposes, nomials is parts. And for us, we're going to say numeric or variable components. So a polynomial is an expression that includes a group of terms combined using addition or subtraction symbols. So example 1 first has us utilizing what is called decreasing degree. Okay? And this is extremely helpful. Things are written in decreasing degree by standard. In other words, this is the norm. Whenever you solve an equation and you go to check it in the back of the book, like let's say you check your odds, you will find that they are always going to be answered in decreasing degree. And if there's multiple variables, it's usually in decreasing degree of the first one in the alphabet. So like if you have x, y, and z within the same polynomial, x would be the degree that is used to order it and decrease. So let's look at this one here. I've got, this is just mine, okay? 3x minus x squared minus 9 plus 2x squared plus 2 minus 5x. The directions for your example 1 are the same as the directions for this example 1, which say simplify and then arrange in decreasing degree. So step 1, simplify, in our universe means combine like terms wherever possible. And to do that, you look for all the like terms, group them together, and I tend to start them with the highest degree. But in order for you to be able to do that, you have to recognize what that means. Well, in decreasing degree of x, the highest degree is going to be the variable with the largest, and we're doing x, decreasing degree of x, the variable with the largest exponent, which is x squared. This is x to the first, this is x to the first, and the 2 and the 9 are not variables at all. They're constants, so they have a degree of 0 when they do not have a variable, so to speak. So here's our first highest degree. Combining a 2 and a negative 1, how many x squareds do you end up with? 1, right? So I've just combined those. My next component is going to be my x's, a negative 5x, because that's got a degree of 1, and a 3x. So negative 5 and a 3x is how many x? Yep, good. Finally, my constants, a negative 9 and a positive 2. What's the result of that combination? Negative 7. Okay, so step 2, decreasing degree, I already did it. That's just how I do these. I automatically do it as I combine them. Amber, are you good so far? How about you guys over there? So far, so good? Yeah, this isn't too terribly difficult. I want to show you another one that has multiple variables in it so that you can understand what I mean by decreasing degree and choosing the first letter within alphabetical order. So here's the next one I want to do. It's very similar. We're going to do x squared y squared minus 8xy4 plus 2x4y plus 5x cubed y cubed plus 2xy4. This is a little trickier to visualize, but in alphabetical order, x precedes y. Would you agree with me? Unless something's changed since last semester. So we're going to do decreasing degree of x, which means the first thing we want to combine is anything with a high x exponent. This is x squared, this is x to the first, x to the fourth, x cubed, and xy4. Of these, which one has the highest x exponent? That one? Yep. Are there any like terms with which I can combine this? In other words, are there any other terms that are x4y? Nope. So 2x4y is going to be the first term. Since x4 came first, I would postulate that x3 comes second. Would you agree? x2, x3, there we go. Is there anything we can combine x3, y3 with? Nope. So x3, y3 is separate from x4, y. What's going to be next? Good. Nothing to combine that with. xy4, xy4. Oh, look, we have something we can actually combine. -8, +2 is what? Yep. This is now written in decreasing degree of x. If you were asked to write it in decreasing degree of y, it would start with -6 xy to the fourth, followed by +5 xy cubed, x cubed, y cubed, followed by x squared, y squared, and then 2x squared y. But since it was in decreasing degree of x, we had our biggest degree first, followed in order by the remaining degrees. How you guys feeling about degrees? Okay. All right. One other question you might be asked with is, what is the degree of the polynomial itself? The degree of the polynomial itself. It's the largest degree within it. Okay, so this one, the polynomial, has a degree of 4 because of that. And this one has a degree of 2 because of that. So if you're asked for the degree of a polynomial, you give me the largest degree of any of the terms once it's been simplified. I mean, technically you can do it before you simplify it because it's still going to be the same, but it's just easier to do it that way. Okay? Next thing we're going to practice is adding and subtracting. Okay, this is the last bit. Adding and subtracting. You guys have done this already. Make sure you copy this though, just for practice, because it is easy to forget how to do this. In your assignment, it's going to ask you, starting with number 10, it's going to have you add them together, and then it's going to say subtract the second from the first. Okay, so you'll have 2 things to do for 10, 12, 14, and 16. But first we're just going to practice just basic adding. And here's what we're going to do. We're going to combine together these polynomials. -3x squared minus 4x plus 9 and 2x cubed minus 4x squared minus 5. We are going to add this polynomial to this polynomial, which for all intents and purposes means you are simply combining. Okay, you're combining like terms. First, identify which one has the largest degree and start with that one. Are there any other x cubes that we can combine this with? Nope. 2x cubed. The next degree is going to be x squared. Looks like I have a -3 of them and a -4 of them over here. What is the result of combining that -3 and -4? Y'all thinking -7? Gosh, I hope so. So we're done with the x squareds. What would the next term be if we continue following our degrees? He's right. Is there anything to combine that with, Percy? That's why you got there. Yep. 4x is dead. 9 and -5. What's the result? Yep. Be careful with your signs, positives and negatives. If you screw those up, you'll end up with the wrong answer. There's your answer. You can also stack these one on top of the other, but you have to make sure that you stack them with the right degree. I'm going to show you what I mean. Here's the first polynomial. The second one, 2x cubed, I would put by itself over here. -4x squared can go right there, and -5 can go there. The top polynomial has no x cubes. The bottom polynomial has no x's. So in order to stack them, you may want to insert zeros as placeholders, and then you can just perform your addition down the columns like that. I don't care how you do it, by the way, whatever you like. Okay? Either way, you're going to end up with the same answer. Subtracting. It's the easiest thing to screw up. I'm going to write this out so that you can see. Subtract this from this. This is how it's written in my sample. Remove the 3x squared polynomial from the 2x squared polynomial. I'm just using those first terms there. Which means 2x squared, if you stack it, is going to be on top. Because I am removing this component from that component. Okay? Remove this from this. Which means the subtraction problem is going to have 3x squared plus 4x minus 5 underneath that top component. I cannot stress the importance of this next thing enough. When you are subtracting in normal math, when you do like 625 minus 204, for example, you'll say 5 minus 4 is 1, 2 minus 0 is 2, 6 minus 2 is 4, and come up with your answer. It doesn't translate quite as easily to polynomials for whatever reason. Because each piece is separated, it makes for an efficient way of screwing up. So here's how I recommend you do it. Instead of subtracting, add the opposite of every term. So that one was positive, now it's negative. That one was positive, now it's negative. That one was negative, now it's positive. That's one way that I've found people find great success. But you have to flip every single one, otherwise you're only going to get the first term right. If I add the opposite of everything, I have a positive 12, I have a negative 13x, and a negative x squared, right? That's correct. Adding the opposite. Another way you can do it is you can speak it the way you guys kind of heard me speak it in your brain. I'll show you what I mean. 2x squared minus 9x plus 7 minus 3x squared plus 4x minus 5. I go one column at a time. 7 minus a negative 5. Well, 7 minus a negative 5 is 7 plus 5, isn't it, folks? 12. Speak the next column. Negative 9 minus a positive 4. So basically, you're adding a negative 4 there. 2 minus a positive 3. You still end up with the same answer. You just spoke it one column at a time. I don't care which way you do it. For me personally, I add the opposite. You'll always see me do it that way. I'm much more successful that way. Okay, it's just the way I am, okay? I don't care how you do it whichever way you like. Either add the opposite or go one column at a time, being very, very careful that what you are doing flips the signs appropriately. So we've added, we've subtracted. The last thing we're going to do is similar to example 4, where you'll find that on top of 169. It's an interesting notebook. All right. All right, the last thing. Okay, here we go. We're going to simplify, and this is similar to example 4. Simplify what? Here we go. It looks like, no, I'm trying to pick. I have 2 different samples I'd like to use. All right. Okay, here we go. A 3b minus 4 plus 5a plus 2b minus, running out of room, 2b a minus 1. All right. To simplify this mess, first you need to do any distributing necessary. Those components, right? Distribute. What is 1a times 3b? Thank you. And what is 1a times negative 4? Bravo. Keep going. Positive 5 times a? Yes. Positive 5 times positive 2b? 5 and 2b is 10b. Good. Last bit. Negative 2b times a. I would flip it to 2ab as well. Don't make it ba because that'll confuse you. B times a is the same as a times b. So list it in the same fashion as the other one, alphabetically, please. Negative 2b times negative 1 is positive 2b. So now we're going to collect all our like terms. Let's start with decreasing degree of a. You might be saying, well, that's kind of tricky, Mrs. Myers. You've got a to the first here, and you've got a to the first here as well, combined with a b. So which one do you choose? In all honesty, I choose the one that's by itself first. That's how you'll generally see it. So that would mean we're going to choose A's. Looks like positive A. And if you don't like crossing them off as you go, I don't care. That's fine. 3 and negative 2 is how many AB? Yep. And that leaves the B by itself at the end of the sentence, at the end of the polynomial. 10 and 2? 12B. Okay? We already did it in decreasing degree. The book tells you to solve it and then put it in decreasing degree. I do it all in one step. If you don't want to do it that way, you want to just combine them however your mind works, that's fine. Just make sure in the end you are in decreasing degree, because you're always going to find your answers that way when you look in the back of the book if you're ever looking at odds. Okay, technically it's not wrong if you give me, unless they specify decreasing degree of A. Okay, like in this case, kind of what I'm trying to show you. Get used to that. It is important and it will make your life easier. Okay, little things like that that are very efficient. All right, guys, I'm going to let you work on your assignment. It's only 12 problems, 2 through 24 even on page 170.